Hello everyone, and thanks for watching Edupedia World videos. In this video, we'll discuss solutions to problems in the first paper of the 2014 JEE Advanced Physics question paper. I'll be following questions as they fall in code 1, but in any other code, the questions will just be shuffled up so you can match them for yourselves. The question 1 in this paper has a circuit with an alternating current So there is a resistance R is equal to 10, the potential of this battery is 50 volts, C is 20 microfarad, and there are two switches here. This is A, B and D. So first we connect A and B, and then after some time, after a time T is equal to 7 pi by 6 omega, we switch from B to D. That means after that A and D are connected, right? And we have some options in which one or more than one is correct. So when you have questions in which one or more than one option is correct, especially such a question in which options are not related, it's best to treat each option as a true or false. So let's look at option A. The magnitude of maximum charge before T is equal to 7 pi by 6 omega is 1 into 10 to the power minus 3. Now, what is the magnitude of maximum charge before this? That will be, you will have Q is equal to, if you have I is equal to I naught cos omega t, then this is dq by dt. Right. Now when the charge will be maximum, dq by dt will be 0. That means I naught cos omega t will be 0, which means omega t is equal to pi by 2, which means t is equal to pi by 2 omega. This is before 7 pi by 6 omega. Right. So t is equal to pi by 2 omega has a maximum of charge, and we can see that after that I will be in the negative direction, so the charge will decrease. So what is the charge between 0 and pi by 2 omega? Integral of 0 to pi by 2 omega I naught cos omega t dt. Now I naught is 1, integral of cos theta is sin theta, so 0 to pi by 2 omega sin omega t by omega, which gives us 1 by omega. Right. So this is 1 by omega. Omega is given to us to be 500, which means this is equal to 1 by 500 or 2 by 1000 or 2 into 10 to the power minus 3, not 1 into 10 to the power minus 3 as is suggested in the problem. So A is false. What about option B? The current in the left part just before T is equal to 7 pi by 6 omega. So the arrow is given in this direction. That means this is the positive current. Right. So from 0 to pi by 2, this is the direction. After t omega t is pi by 2, that is t is pi by 2 omega, the direction will reverse for another pi by 2 omega time. Right. So this for another 2 pi by omega time. The value at 7 pi by 6 omega will simply be I naught cos of 7 pi by 6 omega into omega, that is 7 pi by 6. We know that this is negative because it's in the third quadrant, so it has to be opposite to the arrow. That means counterclockwise. That means B option is again false because B says it will be clockwise. C asks us the immediately after A is connected, the current is R. Right. So immediately after A is connected, what is the current? So for that we need to know the charge on this at T is equal to pi by 6 omega. Right. So for that's easy enough, we'll just replace pi by 2 omega by 7 pi by 6 omega. Right. And this will be sine of 7 pi by 6 divided by omega. Sine of 7 pi by 6 is minus half. So this will be minus 1 by 2 omega instead of 1 by omega, what is minus 1 by 2 omega? That is minus 1 by 1000. So this is the charge, right? So what is the potential difference across this? That will be equal to Q by C, which is 1 by 1000 if you just take the magnitude, by 20 into 10 to the power minus 6, which is equal to, this is 10 to the power 4, so 1 by 2 into 10 to the power minus 2, or 100 by 2, or 50 volts. Right, so the potential difference across this is 50 volts. Right, now some students might make a mistake here. This is 50, this is 50, so the current is 0. But actually, for the first half of the time period, it was going like this, then it was going like this. So actually the positive terminal will be this and the negative terminal will be this. So the current potential difference across this is not 0, it's actually 100 volts. So the current will be 10 ampere. Right, for the first, initially the current is going like this, so the upper plate is positive, the lower is negative. After capital T by 2 or pi by omega time, it reverses, and then this is negative and this is positive. So the potential difference across this is 100, therefore the current across this is 10. So this is true. And Q is 2 into 10 to the power minus 3. Q is the total charge flowing from the battery to the capacitor. Right. So what is initially this charge? Finally this will be the same charge but in the opposite direction. Right. So this is minus plus initially, finally this will be plus minus. So 2 times this charge will be flowing. 2 times this charge will be 2 into 1 by 1000 or 2 into 10 to the power minus 3. So option D is also true, which means the answer to this question is C and D. This is the best way to solve questions like these. Look at every option and see if it's true or false. It might take a little bit of extra time, but it's worth it because you make less errors. Let's move on to the second question. We have a light source of 2 wavelengths, lambda 1 and lambda 2. Fringe widths are beta 1 and beta 2. And the number of fringes for them within a distance y are m1 and m2. So the fringe width is equal to lambda capital D by small d, which means beta 1 is equal to capital D by small d into lambda 1, which is 400. Beta 2 is equal to the same capital D by small d into 600. So the first statement is definitely true. Beta 2 is greater than beta 1. True. What about B, C and D? B says m1 is greater than m2. Now what is m1, m2? We take a certain distance y and the number of fringes between this. So the greater the fringe width, the smaller the number of fringes. The smaller the fringe width, the greater the number of fringes. So if beta 1 is greater than beta 2, if beta 2 is greater than beta 1, then m1 has to be greater than m2. So the second statement is true as well. From the central maximum, the third maximum of lambda 2. What is the third maximum of lambda 2? Right, that is 3 beta 2. And what is the fifth minimum of lambda 1? 4 fringes will give you the fourth maximum, and then the fifth minimum will be half a fringe. So 4.5 fringes, that is 9 by 2 times beta 1. What this gives me is 3 into 400 is equal to, or whether it's not equal to, we need to check. 3 into 400 in this side, 9 by 2 into 400 in this side, 3 into 600 in this side, sorry. So yes, 400 by 2 is 200, both of these are 1800, which is true, so C is obviously true. Right, the third fringe here and the 4.5th fringe here. Right, which is the fifth minimum. Angular separation for fringes for lambda 1 is greater than lambda 2. No, angular separation is simply this distance divided by this distance. If this distance is smaller for beta 1, then the angular separation will also be smaller for beta 1 of a lambda 1. So D is false, which means the answer is A, B and C. Question number 3. One end of a taut string of length 3 meters is fixed. The speed of waves is 100. The other end is vibrating so that the waves are set up in the string. So this is a situation in which one end is fixed and the other end is free. We already know the standard formula for this. Mu is equal to n plus half times V by 2L. V is given to us to be 100, L is 3, so 2L is 6, which means this is n plus half times 100 by 6, that is 50 by 3. Right. So from this we can calculate the other important terms. Omega is always equal to 2 pi mu, which is equal to n plus half 100 pi by 3. And what is K? K is omega by V. Right. So that is equal to this divided by the speed, which is 100. N plus half times pi by 3. Now in the first option, K is pi by 6, which is true for n is equal to 0, and omega is 50 pi by 3, which is true for n is equal to 0 again. So A is true, it can be possible. B says K is pi by 3, which is not possible because n has to be an integer, so B is false. What about C? K is 5 pi by 6, is true for n is equal to 2, and for n is equal to 2, this is again 5 by 2 into 100 pi by 3, so 5 into 50 pi by 3, so 250 pi by 3, so C is again true. For D, K is 5 pi by 2, so this is equal to 5 pi by 2, which means n plus half is equal to 15 pi by 2, or n is equal to 7, which doesn't matter, n plus half is 15 pi by 2. So here you have 15 pi by 2 into 100. So this into 15 pi by 2 into 100 by 3, what do we get? 500 by 2 is 250, so 250 pi t. So D is again true, which means the correct answer is A, C and D. Right. You have to check all of this. Remember that. Right. If you just check speed, then you might get the wrong answer. You have to check these other two terms as well, because it's not only the speed is given, but it's given that it is a sort of string in which one end is fixed and the other end is moving. So you need to account for that as well. Now you have a capacitor which has some part of it separated, a third of the area is separated. So this is, let's say, A by 3 if the total area is A, and this is 2A by 3. Here you have a dielectric constant K and you have no material here. Here you have some material. Right. C is the total capacitance, while C1 is the capacitance of the portion within the dielectric. This is the first source of error. Some students might take the rest of it to be C, but read the question carefully. Right. This gets an area Q1 and this gets a charge Q1 and this gets a charge Q2, which results in an electric field E1 and an electric field E2. Then we need to choose the correct option. Right. So in a dielectric, the electric field is reduced by a factor of K. Right. So we can check many different things. What is sigma in both cases? Sigma 1 is equal to Q1 by A by 3 or 3 Q1 by A. Sigma 2 is equal to 3 Q2 by 2A. And what is the electric field? Electric field is equal to sigma by K epsilon naught. Right. So electric field for the first one is 3 Q1 by K A epsilon naught, and for the second one is 3 Q2 by A epsilon naught. Now to find Q1 by Q2 among other things, we'll need to look at the ratio of C1 and C. Right. So what is C1? What is this capacitor? This will be C minus C1. Because they're in parallel. Right. So if this is C minus C1, the potential difference across both of them is the same, and the capacitance is in the ratio of C by C minus C1. So C1 can be written as A by 3 epsilon naught by D and multiplied by K, and C2 can be written as 2A epsilon naught by 3D. So this is equal to K times some quantity alpha, and this is equal to 2 times the same quantity. The factor 2 comes because the area is different. So from this we can get C1 by C2 is equal to K by 2. Right. From this, C1 plus C2 by C2 or C by C2 is K plus 2 by 2. So out of option A, B, C and D, D comes out to be true right away. Right. Then let's see what is E1 by E2. Right. E1 by E2, we need to find the ratio of Q1 by Q2 for that. But V is the same for both of them. So Q1 by Q2 is again C1 by C2, which is K by 2. So what is E1 by E2? Q1 by Q2 is K by 2, and this is divided by K divided by 2. So you'll multiply it by 2 by K. Which means E1 by E2 is 1, or E1 is equal to E2, which means option A is also true. Which means option B is false, and Q1 by Q2 is K by 2, so option C is also false. Which means the answer to this question will be A, D. Let's look at problem 5. We are given E1, E2 and E3 are the electric fields at a distance r from a point charge q, long wire of linear charge density lambda, and a plane with uniform charge density sigma. So we know the formulas for all three. E1 will be 1 by 4 pi epsilon naught q by r squared. E2 is 1 by 2 pi epsilon naught lambda by r. And E3 is a constant sigma by 2 epsilon naught. So let's look at the options A, B, C and D. A says Q is equal to 4 pi r naught squared. Now these are equal at r naught. So if you equate the first and 2, you can see that 4 pi and 2 pi will leave a remainder of 2. Epsilon naught will cancel. And so, we needed between Q and sigma. Right, so we'll have to equate the first and the third. If we needed between Q and lambda, we would equate between the first and second, but Q and sigma we need to equate between the first and the third. So a factor of 2 epsilon naught will cancel out, and Q will be 2 pi r squared, right, into sigma, not 4 pi r squared into sigma. So A is false. B says r naught is equal to lambda by 2 pi sigma. It's lambda and sigma. We equate these two. We can see that a factor of 2 will cancel directly. So there is no factor of 2. So B is also false. For C, E1 r naught by 2 is equal to 2 E2 r naught by 2. Let's see what is E1 r naught by 2. We put r naught by 2 whole squared here. So it will be 4 times 4 pi epsilon naught q by r naught squared. And they are saying this is equal to 2 times E2 of r naught by 2. Put r naught by 2 here. So 2 lambda by 2 pi epsilon naught r. Now if we take this 2 outside, then we can see that this whole thing inside the bracket is the same as this whole thing, right? Because they are the same at r naught. Both of them are multiplied by 4. So again it will give us the same thing. So C will indeed be true. And for D, we are given E2 of r naught by 2. That is 2 lambda by 2 pi epsilon naught r, and on the other side we are given 4 times E3 of r naught by 2, but E3 is a constant, sigma by 2 epsilon naught, and we know this thing is equal to this whole thing. So 2 and 4 are not the same, so these will not be true, so this is false. which means the answer to the fifth question is going to be C. Let's move on to the sixth question now. So we are given that a student is performing an experiment in a resonance column and the minimum height at which the resonance occurs. So for this standard one end closed, one end open tube, we know what the formula is. Mu is equal to n plus half V by 2L, which tells us that 244 is equal to, now it's the minimum height, so n will be 0, right? So this is just V by 4L, V divided by 4 times, and L is 0.35 plus minus 0.005, which gives us V is equal to 244 into 4 times 0.35 is 1.4 and this is 0.02. Right, and if you calculate it, it comes out to be 341.6 plus minus 4.88. But what is V? V is equal to root of gamma RT by M. So we are given 4 options. We just put the value of gamma RT by M. We are given some useful information to help us in the calculation, and we put in the values and we see whichever one comes within this range. So for A we have neon. In neon the mass is 20 and it's a monoatomic gas, so gamma will be 5 by 3, which means root gamma RT by M will be root of 5 by 3 into RT divided by M, which is given to us to be 20. Don't remember to add into 10 to the power minus 3. And this, if you calculate it with the other things that are given, such that root 167 RT is 640, will come out to be, when you solve this, comes out to be 448, which is not within this range, so false. For nitrogen and oxygen, these are diatomic gases, so gamma will be 5 by 7 and molar masses are given. For neon, again gamma will be, for nitrogen and oxygen, gamma will be 7 by 5, not 5 by 7. And for argon, again gamma will be 5 by 3 or 1.67. And if you put in the values and calculate, I'll not do it here, it comes out to be 354, 331.875 and 340. And 340 is the only one within this limit, so the answer to this question is option D. The other ones are outside our reasonable scope of error. Let's look at question number 7 now. We are given that the heater of an electric kettle is made of a wire of length L and diameter D. It takes 4 minutes to raise the temperature of 0.5 kg by 40 Kelvin. And then you replace the heater by another heater having wires of length L and diameter 2D. So this is an electric kettle, so the heat will be generated by dissipation through the resistance. I square R or V square by R will be the formula for power. And in the next case, we have the diameter has become 2D, so the resistance will change. The material is the same, so resistivity is the same, but the resistance will change, and that will of course change the power given, and that will ultimately change the time taken to heat the water. So the first equation which will be of use will be Q is equal to ms delta T. The total heat supplied, delta Q, will be equal to 0.5 into S. We can put in the values, but even if we don't, we just need the ratios, so it won't matter anyway. 0.5 into S into delta T, which is 40 Kelvin. Right, Kelvin. So this is 20S. 20S is delta Q. What is the power dissipated? We can take that as V square by R. Right, where R is the resistance of the wire and V is the potential difference across the two ends. So that can be written as V square by R we know is rho L by A, so rho L by pi D squared, which is the area. this is the power, this is the heat required. And so what is the power that is required? That is delta Q by delta T, or in this case delta T1, which is the initial time, which is 20s by 4 minutes, which is 240 seconds. I'll just not write the units, it's gonna confuse with this s. So 20s by 240, that we are told is equal to v square pi d squared by rho L. Okay, now this equation can be written as, just to get the values of the constants, rho Ls by v squared pi d squared is equal to 240 by 20, that is 12. Now in the next two cases, here the resistance was rho L by pi d squared. In the next two cases the resistance will be different. So we have two wires, each having length L and diameter 2d. So the resistance of each of the two wires will be rho L by 4 pi d squared. Actually, you know what, d is the diameter, not the radius. So this should be pi d squared by 4, which is the area, right? Pi r square is the area when r is the diameter. But since we need the ratios, it's not going to matter much. So I'm just going to use pi d squared now, and we can assume that d for us is the radius. There's just a difference of a factor of 2. I hope you don't get confused by that, right? So rho L, we'll just take pi d squared, which is proportional to the area, right? It's a constant times the area. The constant will cancel anyway. So rho L by 4 pi d squared is the resistance of one such wire. In the first case, we have two such wires in series. That would mean the total resistance R in series is rho L by 4 pi d squared plus rho L by 4 pi d squared, or 2 rho L by 4 pi d squared. In the second case, R parallel, you have both of them in parallel, equal resistances. So the net resistance is half of that, right? 1 by R plus 1 by R is 2 by R. The inverse of that is R by 2. So half of rho L by 4 pi d squared, that is rho L by 8 pi d squared. And now we need the time taken to raise the temperature by the same amount. So delta Q will be the same, and that means delta Q by delta Ts will be 20s by delta Ts, which has to be equal to V squared by the resistance. Earlier it was rho L by pi d squared, now it is 2 rho L by 4 pi d squared, right? So from this what we get is, we just take this 4 outside for a second and this 2 outside, so 4 by 2 will cancel and give me a factor of 2. And we know rho Ls by V square pi d squared is 12, so this gives me 20 into 12 is equal to 2 delta S, which means delta S is 120 or 2 minutes in series. In parallel you can do so yourself. There's an 8 over here, so there'll be a, instead of there being rho L by 4 pi d squared, we'll have rho L by 8 pi d squared, and there'll not be a factor of 2 here. So instead of 2 here will be a factor of 8. Instead of 2 we'll have 8 here, so the answer will be divided by 4. You can do it for yourself. So it will be 0.5 minutes in parallel. So the answer is B and D. Let's look at the 8th question. So in the question we are given two frictional walls, and the condition given is that the ladder is just about to slip. So we can assume that its limiting case on both the walls, that is friction is equal to mu times the normal in both the cases. This angle is theta, this has a friction coefficient mu1, this has a friction coefficient mu2. So we'll just take this surface to be 2 and this surface to be 1. There's a normal force acting here N1, a frictional force acting upwards, which we'll just write straight away as mu1 N1 because it's the limiting case. There's a normal force here N2 and a frictional force towards right mu2 N2, and of course there's a gravitational force acting at the center mg, and this angle being, this is theta, so this is 90 minus theta, so this is theta. So you can have two equations for force being 0 in the x and y directions. That will give you N1 is equal to mu2 N2 and N2 plus mu1 N1 is equal to mg, which can be written as N2 plus mu1 mu2 N2 is equal to mg, substituting N1 from the first equation, which means N2 is equal to mg by 1 plus mu1 mu2, and N1 is mu2 times this, so N1 is equal to mu2 mg by 1 plus mu1 mu2. Right. So from this we can actually see in the options that they are given such that mu1 is 0, mu2 is not 0, and those are the options given. So we'll have to take care of all equilibriums then, not just translational equilibrium, but the rotational equilibrium has to be 0 as well. So we can write two equations for rotational equilibrium, one about this point and one about this point. About the lower point, the equation will be, if this is L, this is L sine theta and this is L cos theta. So the torque about this point of mg will be mg L cos theta by 2, and it is in the clockwise direction, and that will be equal to the sum of these two torques which are in the anti-clockwise direction. So N1 L sine theta plus mu1 N1 L cos theta. Similarly, the equation about this point will be, for mg it will be mg L by 2 cos theta is equal to, now mg has a torque in the anti-clockwise direction with regards to this point, and N2 has one in the clockwise direction, but mu2 N2 is in the anti-clockwise direction, so that will have a negative sign. So this is equal to N2 L cos theta minus mu2 N2 L sin theta, and mu2 N2 we can directly write as N1. So this equation is N2 L cos theta minus N1 L sin theta. We divide by cos theta this whole equation. What we get is mg L by 2 is equal to, or L also cancels, mg by 2 is equal to N2 minus N1 tan theta. So from that I get N1 tan theta, which is in a lot of the options, that's why I'm doing that, is equal to N2 minus mg by 2. And what is N2? This thing. So mg 1 by 1 plus mu1 mu2 minus 1 by 2, which is mg, the denominator is 2 times 1 plus mu1 mu2, 2 minus 1 plus mu1 mu2 is 1 minus mu1 mu2, or mg by 2 1 minus mu1 mu2 by 1 plus mu1 mu2. Right, now let's start looking at the options. First of all, we can just see from intuition that mu2 cannot be 0. Right, if mu2 is 0, then there is no way that this will stay in equilibrium, because this side will have to slip. Right. A more rigorous way of looking at that would be, if mu2 is 0, then n1 will be 0. Right. If n1 is 0, then mu1 n1 is 0, which means about this point the only torque acting will be that of mg. So it cannot stay in rotational equilibrium, means it cannot stay in equilibrium. That is the rigorous way of doing it, but you can just tell by intuition. If the lower wall, it does not have any friction, there is no way it is going to be able to support it, right? The weight will drag it down eventually. Rigorous way to see that is, if mu2 is 0, then n1 is 0 and mu1 n1 is 0. Both these are 0, that means mg has a torque. So mu2 cannot be 0, that means we can eliminate option B directly. Right, let's look at all the options. Option B is false. Then option A and option D suggest that mu1 is 0. So if mu1 is 0, this equation becomes just mg by 2. So if mu1 is 0, n1 tan theta is mg by 2. Right. So option D is correct, and of course option B is false because n1 is not equal to n2. They differ by a factor of mu. So A is false and D is true. Let's look at option C now. If mu1 and mu2 both are not 0, then n2 is equal to mg by 1 plus mu1 mu2. n2 is equal to mg by 1 plus mu1 mu2. This is a true result. So C is true, which means the answer to this problem will be C and D. The tricky one in this case, in my opinion, would be option B, because if you just look at this equation, if you look at the options and see that they're asking for n1 or n2 tan theta, and you get here and you see that if you put mu2 is 0, you get n1 tan theta is mg by 2. So you'll in a hurry might put option B as correct, but it's false because n1 would just turn out to be 0 in that case. Let's move on to question 9. We are given a transparent thin film of uniform thickness on a convex spherical surface of radius r. So this is a surface of radius r, spherical surface at the end of a glass tube, and there is a thin film on it. And because it's a thin film, we can basically assume that both sides have the same refractive index. And this has n2 is equal to 1.5. This has n1 is equal to 1.4. And this is air. And we are given that rays of light parallel to the axis going from the going through the film from air to glass is focused at f1 from the film. So this is f1, somewhere where it's focused, and going from going from glass to air is fixed at f2. f2 is somewhere here. Actually, we can all tell that f2 will come out to be on the right side as well. It will be a negative focus from that point of view if rays are going in this side. But right now, just to try to tell you what's going on, we are taking rays going in this direction from infinity and going in this direction from infinity. Now, one thing I'll just immediately tell you is a lot of students would try to solve both these questions with this figure. And you can do that, but there's a very big chance, in fact, of making a mistake of a minus sign. So I would suggest that when you're doing it from air to glass, this is the figure you use, but you rotate the figure when you're doing it from glass to air to match with our convention that incident rays always go from left to right. Otherwise, incident rays go from right to left, so you have to take right to left to be the positive direction, right? And you can do that in your head, but there's a chance of making a mistake, right? So in the second case, we'll assume that the rays are going like this, which is the same as if rays are going like this. The answer will be the same, right? So in both cases, we'll have two reflections on a spherical surface. What is the formula for reflection on a spherical surface? Mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. And both sides have the same radius of curvature R, both towards the right. So both positive, right? So the first equation for air to glass will be 1.4 by V minus 1 by U, which is infinity, is equal to 1.4 minus 1, that is 0.4 by R. And R is not given, we'll just have to find the answer in terms of R. So which gives me 0.4 V is equal to 1.4 R, or V is equal to, this is 4 by 10, this is 14 by 10, so 14 by 4, 7 by 2, 7 R by 2. So V for the first one is 7 R by 2, and this is a thin film, so that will be U for the second one. We don't need to change anything because this is not a thick lens or two lenses separated by a distance, right? So just like we do for a lens, we do two planar surfaces, right? And we could actually, if you wanted to, try to use the lens formula, but in the lens formula you have the same medium on both the sides, right? So you have a medium of length which is a mu1 and medium on both sides same which has mu2. So we can't use the length formula in this particular case. But you could try to do this as air to film to air and then going to glass immediately afterwards. Right, it does give the right result. So this equation gives us V is equal to 7R by 2. So for the second one, that will be U. So for the second one, 1.5 by V minus 1.4 by U, which is 7R by 2, is equal to mu2 minus mu1, 0.1 by R. Again, R is still positive. Right. So this gives me 1.5 by V is equal to 1.4 by 7, this 2 by 5, 2 by 5 R plus 1 by 10 R, which is, this is 4 by 5 R plus 1 by 5 R is 5 by 5 R, 5 by 10 R, so 1 by 2 R, which means final V, or rather mod F1, which is the final place where they'll come, is equal to 3R. So we can say that option A is true and option B is false. Now to find F2, from which we'll tell option C and D. So I'll just rub all this. It's just, this question is quite easy, just straightforward application of two reflections at the spherical surface. The only big confusion is, and I'm sure a lot of students would probably make a mistake in that point, is they'll try to do the second case from here, taking this to be the positive direction, then this R and this R both have to be negative and everything has to be taken accordingly. And if you do that, you will get the right answer. But there's a chance of you making a mistake. Right. So if we do it in this fashion, then initially this is 1, this is 2 and this is 3 now. Right. So mu2 by V, that is 1.4 by V, minus mu1 by U, that is 1.5 by infinity, is equal to mu2 minus mu1, that is minus 0.1, that is minus 0.1 divided by R, but R is also minus R in this case. You see why it might make a problem. I'll repeat the signs. We are going in this direction, so U is infinity, is actually minus infinity, but it doesn't matter. This is the second medium, this is the first medium from our perspective of refraction. So mu2 by V minus mu1 by U is equal to mu2 minus mu1, that is minus 0.1, divided by R, the radius of this surface, which is in the negative direction because this is the direction of incident light. So which gives me 1.4 by V is equal to 1 by 10R, or V is equal to 14R. For the second one, 1 by V minus 1.4 by U, U is now 14R, is equal to minus 0.4 by minus R again. So which tells us 1 by V minus 1 by 10R is equal to 4 by 10R. Right, 0.4 is 4 by 10, this is 1 by 10. So which means 1 by V is equal to 5 by 10R, which means V, or mod F2, is 2R. So along with option A, option C is correct and option D is wrong. Right, straightforward application of the formula. Let's move on to question 10. We are given a circuit. I'll just draw that first. V1, okay, so this is V1, this is V2 with polarity opposite of that of V1, R3, R2, R1. So two ideal batteries, three resistances. We want the current and resistance R to be 0. The current in this resistance to be 0. Now, personally, obviously there are many ways to solve the standard circuit equation. What I always like to try to do is try to assume one negative potential to be 0 and go from there. Because you can set any one arbitrary to be 0 and that takes care of one less variable. Right? Instead of having 5 variables where only the difference matters, you can set 1 to 0 and you have 4 variables. So I'll just set this to 0, which means the potential here is 0. And then the potential here has to be V1. Right, and the potential here has to be V1, and the potential here is V1, and the potential here is then this is positive V1 and then another positive, so this is V1 plus V2 and this is 0. So hang on, let me do a mistake. This will be some V dash, or let's take it to be V3. Right, so this is V3 plus V2, right? We cannot say the potential here will be the same, right? Because this is going through a resistance. So here over a wire it will be the same, here it won't be the same. Now, for the current in R2 to be 0, these two should have the same potential. That means we want V3 to be 0. That means we want this to just be at V2 and this to be at 0. Well, what does that mean? If the current here is 0, current is going in this direction, coming in this direction. No current is going in this branch, it's going in this direction, going in this direction, coming in this direction. So the current through this resistance has to be the same as the current through this resistance, which means V1 by R1 is equal to V2 by R3, or V1 by V2 is equal to R1 by R3. Any set of V1, V2, R1 and R3 that follows this combination will result in there being no current in R2. So we can just look at this. Option A satisfies this, so A will be true because the ratio everywhere is 1. For option B, V1 and V2 have the same ratio as R1 and R3. R2 doesn't matter, you can just remove that from the equation. For C, V1 by V2 is 2 and R1 by R3 is 1 by 2, not 2. So it is false. And for D, V1 by V2 is 1 by 2 and R1 by R3 is 1 by 2. So D is true, which means the answer is A, B and D. Let's move on to the integer type questions now, starting with question 11. We have two planes A and B flying with constant velocity with 30 and 60 angles with the horizontal. So this is the plane B. Making an angle 60 degrees. And this is the plane A, making an angle 30 degrees. The speed of A is 100 root 3. And we are given some other information. At t is equal to 0, an observer in A finds B at a distance of 500 meters, moving with a constant velocity perpendicular to the line of motion. So, just qualitatively, we are looking at B with respect to A because the observer is in A. The velocity of B with respect to A will be the velocity of B minus the velocity of A. So if this is A, this will be the negative of A, and the sum of those two will be in this direction, somewhat. Right. Now what we are given is this velocity is perpendicular to A. It is perpendicular to the line of motion of A, which is the velocity of A. And it is a constant. It has to be a constant because both A and B are constant vectors. Right. So B minus A is perpendicular to A, that is given us, and some other information is asked. So let's just write down the velocities straight away. Velocity of A will be V cos 30 I cap, that is 100 I cap, 100 and hang on. Yeah, 100 root 3 into root 3 by 2, that is 150 I cap, sorry. Plus 100 root 3 into 1 by 2, that is 50 root 3 j cap. And the velocity of B, we don't know the speed, let's assume it's V, so it's V cos 60 I cap that is v by 2 I cap plus root 3 v by 2 j cap. What is v of b with respect to a? That is vb minus va. That is v by 2 minus 150 I cap plus root 3 by 2 minus 50 root 3 j cap. And we are given that this vector is perpendicular to VA. So the dot product of this vector with VA should be 0. That means 150 times V by 2 minus 150 plus 50 root 3 times root 3 by 2 minus 50 root 3 is equal to 0. Which means 75V minus 22500 is equal to, this is 25 into 3 is 75 minus 2500 into 3 is 7500. So there's a V here as well, right? So which gives us, this is 0. So which gives us 150V is equal to 22500 plus 22500 plus 7500, that is 30000, which means V is equal to 3000 by 15, which is 200 meters per second. So we know the speed of V now, that is 200 meters per second. So now we can calculate the magnitude of V of B with respect to A. So what that would be is V by 2 minus 150. That is 100 minus 150, that is 50. We just need the magnitudes. So 50 squared plus, now this is root 3 by 2 V. Root 3 by 2 times V minus 50 root 3. We can just take root 3 common. V by 2 is 100 again minus 50, that is 50, and we can multiply that by root 3. So that is 50 squared into 3. This is 50 squared into 4. The root of it will be 100. So that means mod of V of B with respect to A is equal to 100 seconds. So it's moving in this direction perpendicular to A at a speed of 100 seconds. And also it's given that A finds B at a distance of 500 meters. So this distance is 500 meters and the speed is 100 meters per second. So the time taken will be 5 seconds, which means the answer will be 5. Right? Now there's actually an easier way to do this. You do not have to assume all of that. This question could actually have been solved purely geometrically as well. If we take this to be VA, then this is VB and they are at an angle of 30 degrees. And VB minus VA will be this vector. And if we are given that this vector is this angle is 90 degrees perpendicular to VA, then what is this magnitude? This by VA will be tan 30. So this is VA tan 30. 100 root 3 into 1 by root 3, which is 100. So we directly get this value 100, which we got from here after a lot of work. The speed is 100. This distance is 500. So the time taken will be 5 seconds. So the final answer is 5. Question 12 now. The vernier scale lies between 3.2 and 3.25, and the 20th division of the vernier scale coincides with one of the mean scale divisions. When you add a load of 2 kg, it still stays between 3.2 and 3.25, but now the 45th division coincides, and the length and the cross-sectional area are given and the least count is given. We want the percentage error in Young's modulus. So what is Young's modulus? FL by AX. Now since nothing is given about L, F and A, we'll have to assume that they are known with reasonable accuracy, right? So from that what we get is dy by y is equal to, we are just talking about magnitudes obviously, dx by x right? Because we'll take ln and then we'll take dy. You know how to do that. These are the fractional errors. So the fractional errors will be the same in both the cases. Now x initially is at a particular main scale division, so it doesn't really matter. It's 3.2 into 10 to the power minus 2 this, and initially this is at plus this into 20 times least count, and finally it's this plus 45 times least count. So the change, which is the actual elongation x we are the change, which is the actual elongation x which we are trying to measure, is the difference between these two, and that is 25 times the least count, or 25 into 1 into 10 to the power minus 5. Right, and so this is x, and what is dx or delta x? That is the least count. It is 1 into 10 to the power minus 5. So the fractional error dx by x in x, which is the same as the fractional error in y, because if there was a 2 here, then there would be a 2 here. You know how the formula goes, right? So dx by x into 100 is simply 1 into 10 to the power minus 5 by 25 into 10 to the power minus 5 into 100, or 100 by 25, or 4%. So the answer to this question is 4%. Let's look at the next question. Question 13. We are given a uniform circular disc of mass 1.5 kg and radius 0.5 meters, and it is at rest on a horizontal frictional surface, and 3 forces are acting along an equilateral triangle, and we need the angular speed. So it's basically a question of trying to calculate torque. So this is our disc of radius r and mass m, and 3 forces are acting along an equilateral triangle like this. So the 3 forces will have the same torque by symmetry. We just need to calculate any one torque and we can get all 3. So we need this distance first, right? Because this will tell us what the torque is. This is 90 degrees. This, if this total is 60 degrees, this is 30 degrees. So this distance, let's call it small r, is equal to r sine 30 is equal to r by 2. And we are given the radius directly, so we know what r is, and the torque will be F into r by 2 for one of them. That will be equal to 0.5 into 1 by 2 or 1 by 4. Right. So 1 by 4 is the torque due to 1, so the total torque is equal to 3 by 4. This is equal to I alpha. I is 3 by 2. This is mr square by 2. So 1 by 2 into 1 by 2 into 1 by 2 whole squared, mr square by 2 into alpha. So what is alpha? 3 and 3 cancel. Alpha comes out to be 2. And if alpha is 2, 1 second after applying the forces, this is all constant, so v is equal to u plus at, or omega is equal to 0 plus alpha t. So 1 second afterwards, the omega will also be 2. Straightforward question. All you needed to do was calculate the torque. Right. Let's go to question 14. 2 parallel wires in the plane of paper are at a distance x0 apart, and there's a point charge moving with the speed u to distance x1 from here, and we only know that it's moving in this xy plane, right? That's all we know. And when wires have a current of magnitude I in the same direction, radius is r1. So same direction means radius is r1, opposite means radius is r2. And that's understandable. Anytime this object moves in the xy plane, the magnetic field will be in the z direction, whether positive or negative. So it will move in a circle, and we already know what the formula is, mv by qb. So it's inversely proportional to b. That's the important thing. Right, the other things are independent of b. Right. So we are given that when they are in the same direction, the radius is r1, when they are in the opposite direction, radius is r2, and we are given the ratio of x0 by x1. So r1 by r2 will be the same as b2 by b1. Right, that's all we need. And 2 is when they are in the opposite direction, so b2 will be, if they are in the opposite direction, both of them will have a magnetic field here in the same direction, that is going inside the plane. So B2 will be mu naught I by 2 pi 1 by x1 plus 1 by x0 minus x1, which is this remaining part. And B1, when they are in the same direction, the current will be opposite here, so it will be mu naught I by 2 pi 1 by x1 minus 1 by x0 minus x1. Right, and we don't actually need to worry about the sign because radius depends on magnitude, but even if we did, you could look at x0 by x1 and see that this is the positive term. Right, the ratio of these will be b2 by b1, which is the answer we are looking for, r1 by r2, which will be, this is x0 minus x1 plus x1, so x0 by x1 times x0 minus x1 divided by x0 minus x1 minus x1, so x0 minus 2x1 by the same denominator, x1 times x0 minus x1. So these denominators cancel. This is x0 by x0 minus 2x1, and we know x0 by x1 is equal to 3, so just divide it by 3, we get x0 by x1, which is 3, divided by x0 by x1, which is 3, minus 1, minus 2 times 1, because we divided by x1, which is equal to 3 by 1. So the answer to question 14 is 3. Let's look at question 15, which is a question on dimensional analysis. So we need to find the distance d over which a signal can be clearly seen, and it depends on the mass density rho. We'll assume that it's rho to the power a, the intensity or power per area s of the light, so s to the power b, and the frequency f, which we'll assume to the power c. That's all we need to do, and once we find out these powers, we'll need to find out basically the reciprocal of b, that is what is asked. So we can just write, this is L. What is density? Density is easy, ml to the power minus 3 kilogram per meter cube to the power a. What is S? S is power per area. Power is force into velocity. So S will be force mlt minus 2 into velocity lt minus 1 divided by area, which is L2 whole to the power of b. And F is just 1 by t, so it's 1 by t whole to the power c, which means L is equal to m to the power a plus b, L to the power of minus 3a, and here we don't have any power of L because L and L cancel with L square, and here also we don't have any power of L, and t to the power of, here we have minus 3b and minus c, minus 3b minus c. That's it. This means a plus b is 0, minus 3a is equal to 1, and minus 3b minus c is equal to 1. Sorry, is equal to 0. So the first thing means a is equal to minus 1 by 3, which from this means b is equal to 1 by 3. If b is equal to 1 by 3, s to the power 1 by 3 is the power, which is given to us to be s to the power 1 by n in the question, which means n is again 3. So the answer to question 15 is also 3. Let's move on to question 16. We are given that a galvanometer gives a full scale deflection with a current, let's call it IG, of 0.006 ammeter. When you connect it to a resistance of 4990 kilo ohm, 4900 ohm, it is a voltmeter in the range 0 to 30 volts. Now we know what happens in a voltmeter. This is the galvanometer and the resistance is connected in series. Why? Because this thing will be attached in parallel to the circuit, and a high resistance means a very low current is drawn here, which means that the potential difference across this point is not changed by a very big amount, right? So this has its own resistance, let's call it Rg, this is 4990, and the voltmeter has a range of 0 to 30 volts. And this is a full scale deflection at 0.006 amperes, which means at 30 volts the deflection is 0.006 ampere. It can't go further than that. That means 30 volts is equal to 0.006 amperes multiplied by the resistance, which is 4990 plus Rg, right there in series, which gives me, this is, you take 3 here, so this is 30,000 divided by 6, which is 5000, is 4990 plus Rg, which gives you the resistance of the galvanometer as 10 ohms. Now next you are converting it into an ammeter, and when you convert it into an ammeter, you have your galvanometer and you put a very small resistance in parallel with that and connect it in series with the circuit. The reason for that is, if there is a very small resistance, most of the current will go through that and only a tiny fraction will go through the actual ammeter, because only a tiny deflection will give us the maximum deflection. So we've scaled an ammeter up. So in this case the current is I. That means the current through this thing, if this is Rg, the current through the galvanometer is I times small r by R plus Rg. We know this formula, right? This is for parallel. They are divided in the inverse ratios. Since R is very small, most of the current will go here. A tiny fraction will go through this, which is proportional to small r. Right? So this is what we are given, and the range is 0 to 1.5 amperes. Which means 1.5 is equal to, 1.5 into small r by small r plus 10 is equal to 0.006 amperes, right? So 1.5 goes here, which means that 0.006 goes here, which is the maximum possible value. So we'll need to solve that. I'll just rub this voltmeter part. Yeah, so the equation is 1.5 or 3 by 2, 3r by 2 times r plus 10 is equal to 0.006, which means 3r is equal to 2r plus 20 times 0.006. Or we can take this to this side, so this will be 1, 2, 3, 3000 by 6, which will be 500. R is equal to 2r plus 20, or 498r is equal to 20. Now we are given that r is equal to 2n by 249. So we put 498 into 2n by 249 is equal to 20. This gives us 2, which means 4n is 20, which means n is equal to 5. The reason they gave that was just so we could get an integer answer. The actual answer is whatever r is, but we said that is equal to 2n by 249. So n is equal to 5 is the answer to question 16. In question 17 you have a curve that's not really a circle, it's an ellipse, and an object is going from P to Q. This is 4 meters, this is 3 meters, this is 90 degrees, and this is the straight line journey. Right? So the force, it's given that it acts along the rail from P to Q and the magnitude is 18. The force always points in this direction. Even when the object is here, the force always points in this direction. And the magnitude of the force is 18. And we know if the force is constant, we can just write down the work done by the force as F dot d, where d is the displacement vector. In this case, the displacement vector is the vector PQ. It doesn't matter how we got there. So the work done is 18 into d. They're in the same direction, parallel to each other, and this distance is 5 meters. So it is 90 joules. This is the work done by this force. We are asked the kinetic energy, and the answer would be 90 if there was no other force, but there is a force of gravity acting downwards. And the work done by the force of gravity will be minus mgh, because it's going upwards. So that is minus 1 into 10 into this height is 4 meters, which is minus 40 joules. So 90 joules is the total work done by the force, minus 40 is the work done by the gravity, which means the total work done is 90 minus 40, which is 50 joules, which is the change in kinetic energy. Initial kinetic energy was 0, so final kinetic energy is 50. That means n is equal to 5. Let's move on. Actually, I'm noticing that it's not really given that it starts from rest. I guess you have to assume that. Consider an elliptically shaped rail block of mass. Yeah, you have to assume that it starts from rest at P. It should be given in the question. Let's move on to question 18. We have a rocket moving in gravity-free space with an acceleration of 2 meters per second square. So it's a non-inertial frame. Within this frame, we'll have to apply a pseudo force to every object. Right. So this is an object A moving with 0.3 meters per second, and this is an object moving with 0.2 meters per second. And the pseudo force will be towards the left, so the acceleration on both of them will be towards the left and 2 meters per second square. So this one will go and come back. In fact, the velocity is so small and the acceleration compared to it is so large that it will quickly go and come back. But this one will continue moving left, and at some point they'll meet, right? So let's look at the motion of the first object for a second. How much time will it take to go and come back? In that case, s will be 0, will be ut minus half at square, 0.3t minus 1t squared, which means t is equal to 0.3 seconds. That means it goes and comes back every 0.3 seconds. After 0.3 seconds, it again goes and comes back, then goes and comes back. Right. What is the displacement of this object? S is equal to 0.2t plus half into at square. That is plus t squared. Right. And when we look at the motion of the second object, since this is moving in such small paths, we'll first try to find out when it would reach this end point, and then approximately near that point it would reach here. So if we take this is equal to 4, that means 5t square plus t minus 20 is 0, or 5t squared when you can't make a perfect square, it's alright to do with minus b plus minus, and maybe there isn't any perfect square. So t is equal to minus 1 plus minus root of b square, that is 1, minus 4ac, 20 into 5 is 100, plus 400. Yeah, so there's not really any perfect square, but that's fine. So this divided by 2a, that is 10, which is equal to, we can just take root of 401 to be 20 approximately, and the only plus sign will count, so minus 1 plus 20 by 10 or 19 by 10 or 1.9 seconds. And this keeps making motions in 0.3 seconds intervals, so at 0.8 second it will be here, and then it will start moving again. So the approximate collision will happen around 2 seconds. right? So the answer to this question is 2 seconds. We need an integer answer, right? Let's move on to the next question. Question 19. A horizontal circular platform of radius 0.5 meters is free to rotate about its axis. By the way, just in case, in the previous question, if you wanted to try to calculate the actual answer, I did try to do it and you can get it, but you won't get an exact answer, it will be near to, and that's because you have that term root 401, which you approximated to 20, right? So if it's between 1.8 and 2.1 and it has to be an integer answer, you know what the answer is going to be, it's going to be 2, right? So, okay, let's move on to the next one. 19. Radius and mass is given, it is free to rotate. 2 massless spring toy guns are attached and they fire horizontally balls in opposite directions and the rotational speed of the platform. So this seems like a simple question, just angular momentum conservation. The angular momentum of the 2 balls immediately after being fired is 2 mvr. That is 2 into 0.05 into V, which is 9 into 0.25. This is not the radius of the disc, this is the r, the distance from the center at which they are fired. So this comes out to be 2 into 0.25 is 0.5 into 9 is 4.5. So 4.5 into 0.05. We don't need to worry about the exact value. This has to be equal to the angular momentum of the disk afterwards, because they're in opposite directions and initially the angular momentum was 0. So this is equal to mr squared by 2, 0.45 into 0.5 into 0.5 by 2 into omega, right? So you can just cancel this with this and you'll be left with 10. 10 into 0.05 is 0.5, which cancels with 1 0.5. And you get finally omega is equal to 4. So the answer to question 19 is 4. This is one of the simplest questions in the paper. Simple angular momentum conservation. Let's do the last question of the physics paper. We are given a PV diagram. So this is A, this is I, this is F, this path is B. And we are given some things. We are given that UI is 100 initial energy and it goes around 2 different paths. WAF is 200, WIB is 50 and WBF is 100. And the heat supplied is QIF, IB and IBF. If the internal energy of the system in the state B is UB equal to 200 and you are given QIAF is equal to 500 joules, you need to find QBF by QIB. Right, so there's a lot of things to work here. We can start in many different places. The one thing which I can really see is UI is 200. This is 200 here, and at B, 100 here, and at B it's 200. So the difference is 100. So from I to B, delta U is 100, and the work is 50. So delta Q or QI to B will be 150. Right, so this is clear. Now we need to find QBF. Right, so do we know WBF? That is 100. So QBF is equal to 100 plus delta UBF. Right, but we don't know delta U at this point. We don't know the final U at this point. Well, we can calculate that. We know QIAF is equal to 500. So the total heat supplied from I to AF is 500, and the total work done from I to A to F Hang on, we don't know the total work done either. We know the work done from A to F. The work done from A to F is 200. Yeah, so obviously the work done from I to A is 0, obviously. Right, because it's an isochoric process. So the work done from I to F is 200. Right, and the heat supplied is 500. So the change in internal energy has to be 300. If it's 100 here, it has to be 400 here. And if the U is 400 here and U is 200 here, so delta U is 200. So QBF is 100 plus 200, that is 300. There are many different ways you could go about. Just apply Q is equal to U plus W across any 2 points. Q and W depend on the path, U just depends on the initial and final points. So the ratio of these two will be 300 by 150, which is 2. So the final answer is 2. Thank you.